The definite integral of f of x from a to b produces a value or a signed area, which may be positive, negative, or 0. However, if you are asked to find an actual area, that area cannot be negative. To find the area of a region between two curves, you will evaluate the definite integral from a to b of f of x minus g of x if f of x and g of x are continuous and f of x is greater than or equal to g of x on that interval. For functions of x, informally we'll call it top curve minus bottom curve. That's what you'll be integrating. For functions of y, right curve minus left curve. The integral of f of x from a to b is this area under this curve. The area under g of x is not part of the area we want to find. And that's why if you take the area below f of x and you subtract the area below g of x, then you will get the area between the two curves. For example 1, find the area of the region bounded by y equals x squared plus 2, y equals x, from left side is 0, right side is 1. Which curve is the top curve? Well, visually it is this one. That would be the x squared plus 2 function. Our lower curve is a line represented by y equals x. Our integral needs to evaluate the area between the blue curve and the purple curve. Our left boundary is 0, our right boundary is 1. The upper curve is x squared plus 2. The lower curve is x. Let's integrate. And that will equal 11 over 6. Sometimes you have to find where two curves intersect to determine boundaries for your regions. These intersections will provide you with limits of integration for your integrals. You must show an equation setup even when using a calculator to find the intersections. Super important to get the credit for AP. This time we have some functions of y. Notice that if this were y equals x squared minus 3, it would just be a parabola shifted down 3. But this time, since it's x equals y squared minus 3, it will be a sideways parabola shifted left 3. Y equals x plus 1. This is a function of x, which will make it easier for us to graph. But before we can use this function in the integrand, it will need to be x equals, so a function of y. For the integral with functions of y, we do right curve minus left curve. And that will give us the area in here. Notice that part of this area is below the x-axis, but these questions are asking for actual area, so it doesn't matter, our answers will always be positive. Our limits of integration, however, is not left to right now, it would be least to greatest. And we're concerned about the y. What does the y part of this intersection equal? This intersection is at -2, -1. This intersection is at 1, 2. But wait a minute, I didn't show an equation for how I found those intersections. How would you solve for a and b? You would make the left function equal to the right function. And yeah, those are the y values that I got for my limits of integration. Right curve minus left curve. Be sure you're subtracting the entire left curve. Now that we've set it up, we can integrate. That gives us an area of 9/2. Set up integrals for the total area of the regions located between the two curves as shown. You may use a calculator. One of these functions is cubic, this other one is quadratic. They didn't even give us a left boundary or a right boundary. So unless these intersect at an integer, it looks like I'm going to have to use a calculator to save my upper and lower boundaries. First of all, how do you solve for your upper and lower boundaries? You set up an equation making f of x equal to g of x. To find a and b, you put this equation into your calculator. Then it's going to ask for a value of x that's near the solution that you're looking for. I would type in x equals 2, and on the other end, I would type in x equals -2. Then press alpha enter to solve. The solution for x that's closest to -2 is -2.024846, and so on. What we need to do is save this value in our calculator so we can refer back to it while integrating. We don't want to round intermediate values like this one, otherwise we won't get the most accurate answer. This is the x value it's giving you. Now click second mode to quit. This will take you to the home screen. Type in x using the variable button, then press store, and then you'll choose a letter that you want to store it as. You can store it as A if you press alpha and then the math button. Press enter to be sure that your calculator has stored it. And now B, our upper boundary, is just the positive version, 2.024846. And then store your upper boundary B. But this intersection in the middle is also going to break up our integrals. That one's easy though, because that is happening at x equals 0. From a to 0, our cubic function is the upper curve. From 0 to b, the parabola is the upper curve. So it's time to set up our integrals. Integral from a to 0 will be cubic curve minus quadratic curve, plus the area between 0 and b, between the curves. Now our upper curve is the quadratic, and our lower curve is the cubic. To save yourself from having to type out all of this, I actually went to y1 and set it equal to x cubed minus x squared. Then for y2, I set it equal to negative x squared plus 4.1x. And so another way you could write this integral would be y1 minus y2, adding this time y2 minus y1. To refer back to y1 or y2, you just click the vars button and then function, and then you can refer to y1 or y2. And then for the lower limit a and this upper limit b later on, remember to use the values that you stored for a and b for your upper and lower limits. After all that is said and done, we finally get an answer. That is 8.405. The average value of a function represents its average height. To discover the formula for the average value of a function, first we will draw a horizontal line segment from x equals a to x equals b in the figure at right, which could represent the average height of f of x on a to b. So I'll kind of pick halfway between. Then find the area of the rectangle that you have formed here. If our height is h, then base times height is b minus a times height. Now I can rewrite area under a curve as a definite integral if the definite integral from a to b of f of x is equal to b minus a times height, or times the average height. If I want to solve for that average height, I would divide both sides by b minus a. So I have the height, or average value of a function equal to the integral from a to b of f of x over b minus a, or times 1 over b minus a. F of x must be continuous on a to b to find the average value. Find the average value of x cubed minus x on the interval 0 to 2 without using a calculator. 0 is a, b is 2. Average value of a function known as f of c is equal to 1 over b minus a times the integral from a to b of f of x with respect to x. Time to integrate. And our average value of the function is 1. Use your calculator to find the value of c in the interval 0 to 2, where f of c is equal to the average value found in example 4. So f of c is equal to 1. So we're looking for where our function f of x is equal to x cubed minus x. They said you could use a calculator. So our value for c, when you solve, x is equal to 1.325 or 1.324. There may be other x values, other solutions, but remember we're looking for the solution on 0 to 2. So I just had the calculator guess for the solution that was closest to the number 1, and then you should get the correct value for c.